Hello grade 10, hello everyone. In this video I'm going to solve our second worksheet. So let us start by the first exercise. So in the first exercise, it's about vectors. We have the square ACEG and the points BD, FH are the midpoints of the segments AC, CE, EG, AG respectively. So we are going to start by the first part where we want to add two vectors. Of course, the addition of two vectors is a vector. So two vectors, the addition of two vectors that are issued from the same point, which is I, they form a quadrilateral. ID plus IG, they form the quadrilateral IDFG. And in this case, the addition of those two vectors is the diagonal IF. Okay, now HI plus CB. This is HI, this is CB. So as you can see, those are two vectors that have opposite direction and they have the same magnitude, so their addition is 0. Now AB plus CK plus HF. AB and CK and HF are not related, so I'm going to replace them. So for example, instead of AB, I'm going to put BC. Because BC plus CK, it's BK. So instead of AB and AB and CK, it's now BK. And instead of HF, I'm going to put JL. Why? I will let you see. So instead of HF, I'm going to put GL, and instead of BK, I'm going to put AJ, because they have the same magnitude and the same direction. Now what's AJ plus JL? It's LL. Now the image of D by the translation of CI. So this is CI. So what could be the image of D by the translation of CI? So I'm going to go with the same magnitude and the same direction. So it's F. So the image of D is F as the image of C is I. The same thing. Now we can say that what are the two triangles that are symmetrical to each other with respect to CG? So this is CG. What are the two triangles? If the first one is BIH, which is given, then the second triangle is DIF, that are symmetrical to each other with respect to CG. Now the last part, the image of the which triangle is the image of triangle by the translation vector Fi plus AB, Fi plus AB. Instead of AB, I'm going to put HI. So the image of BID is HIF. I wish it's clear. That's everything that I need in vectors. Let us go for the second question. In this question, which is about trigonometric, in the first part, we are given sine x equals 3/7, and we need to find cosine x and tangent x. The only relation that you know that relates sine x and cosine x together is sine squared x plus cosine squared x equals to 1. And you just replace, instead of sine squared x, 9/49 plus cosine squared x equals 1. And now cosine squared x equals 1 minus 9/49, which is 40/49. And now cosine x equals radical 40/49, which is 2 radical 10/7. Now after finding cosine x, so now we have sine x and cosine x. So what we should do is tangent x equals sine x over cosine x, which give us 3/2 radical 10. And always remember, in the denominator we shouldn't have radical, so we rationalize the denominator by multiplying by radical 10. So the final answer is 3 radical 10/20. And now in part B, we were given triangle ABC where AB equals AC equals 6 centimeters. So this is an isosceles triangle, and the height BH measures 3 centimeters. Let us draw the figure. So first I'm going to construct the triangle. This is ABC. AB equals 6 centimeters and AC equals 6 centimeters. And we were asked to construct the height BH. So it's issued from B toward AC. So it forms a right angle, and this is H, and BH is 3 centimeters. This is the given. And now we are asked to calculate the measure of BAC. So BAC, it's like BAH. It's a right triangle at H. So I'm going to use the trigonometric ratios in order to find the measure of BAC. Why? Because if you look at triangle BAH, the only given about angles is that H is 90, and we can't know the two other angles. Okay, so I'm going to use the trigonometric ratios. So calculate the measure of BAC. According to BAC, if you look at this angle, which is located here, what do I have? I have this side, which is 3, and I have the hypotenuse, which is 6. 3 is the opposite for angle A, so I'm going to use opposite over hypotenuse, which is sine. So I'm going to use sine BAC equals opposite over hypotenuse. Opposite, which is 3, and the hypotenuse is 6. Now sine BAC equals half, and in order to know the measure of the angle, we are going to use the calculator, and BAC equals shift sine half, which is 30 degrees. Now deduce the measures of the angles of triangle BHC. In BHC we only have H is 90, but we know that triangle ABC is an isosceles triangle. Then ACB and ABC have the same measure, which is 180 minus 30 divided by 2, which is 75. So ACB and ABC, each one of them is 75 degrees. Then HBC equals 180, because this is already 75 and this is 90. So 90 or 180 minus 90 minus 75 equals 15. So this angle is 15. So we calculated the measure of each angle in triangle BHC. Now let us continue on the same question. So we need to calculate the exact value of AH and CH. Let us put the drawing again. Don't forget that this angle here is 75 and the second angle here is 15. Okay, just to pay attention. Now in order to find AH, the first thing you have to do is to use either sine A or cosine A. Both of them will lead you to the answer because I have the exact measure of A. Anyway, I used just a minute. I used cosine BAH, which is adjacent over hypotenuse. And BAH, it's already given 30. So cosine 30 is radical 3 over 2 equals the adjacent, which is AH, that I need to calculate, over the hypotenuse, which is 6. Now after cross multiplication, AH is equal to 3 radical 3. But you know that AC, all of it is 6. So 6 minus 3 radical 3 equals HC. Now, prove that tangent 75 or tangent ACB equals 2 plus 3 radical 3. I'm just going to apply the rule for the tangent. Tangent equals sine over cosine or opposite over adjacent. So the opposite of ACB is 3 and the adjacent is 6 minus 3 radical 3. Now after rationalizing, you are going to find that tangent 75, don't forget that you rationalize, you multiply by the conjugate of the denominator. So the denominator is 6 minus 3 radical 3, so you multiply by 6 plus 3 radical 3. And tangent 75 is 2 plus radical 3. In the same concept, we are going to calculate tangent 15. So I'm going to use Tangent 15 is equal to opposite over adjacent. The opposite is 6 minus 3 radical 3, and the adjacent is 3, and it's 2 minus radical 3. Now calculate BC to the nearest 10 to the power minus 1. To calculate BC, you can use B, C, or even H. But I chose to use cosine 15 is equal to adjacent over hypotenuse. Cosine 15 is 0.96. The adjacent is 3, which is BH. And the hypotenuse is BC. And now after cross multiplication, BC it's 3 point something. But because they asked us to give it to the nearest 10 to the power minus 1, so I rounded the number. It's 3.1. Okay, that's everything.